welcome back to our Pythagorean theorem video. This is going to be part B, focusing on real-world problems. Remember that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs that form the right angle, and c is the length of the hypotenuse, that's the side opposite of the right angle. Alright, so Pythagorean theorem is probably one of the most used actual real-world math applications out there, because people are constantly building. There's just so many examples of jobs and real life projects and school projects where you need to find missing sides of triangles, and Pythagorean theorem helps you with those right triangles. So in this particular problem, it says a rectangular bookshelf needs a diagonal support brace. So we're talking about putting it from here to here. Well, you cannot see that. Oh, there it is. A diagonal support brace. Which piece of wood should we use? So it is a multiple choice question. We've got some answer choices over here. 30 inches is the bottom of the bookshelf, 40 inches is the side of the bookshelf. We're trying to find this diagonal. The diagonal is the hypotenuse. My right angle is right here. So I can say 30 squared plus 40 squared equals c squared, and the c represents the hypotenuse, not the actual answer for the multiple choice question. So this is going to be 900 plus 1600 equals c squared. So that's going to be 2500 equals c squared. Then again, my last step is going to be to square root both sides. Luckily 2500 is a perfect square and we get 50. So 50 equals c. So that means I need this diagonal to be 50 inches. Well, if I come over here, I thought we just calculated 50 inches. So where is my answer? Well, let's think about this. 24-inch piece of wood is not going to cut it. 36 inches isn't going to work either, not even 48 inches. 64 inches, at least if I have that long piece of wood, I can cut down to the 50-inch diagonal that I need. So the only answer choice that makes sense in this particular example is D, 64 inches. So televisions are measured by the lengths of their diagonals. So we're trying to find the measure of this TV. So again, the diagonal is going across here. Oops, let me get this. Going across right there, that's the diagonal. The diagonal will be our hypotenuse because that's our right angle there. So I'm actually going to drag this 28 inches down. Oops, I'll just leave it there. Drag that side down, measure this one 28 inches so that I actually see my right triangle there, but I still need C, so I'm still looking for the hypotenuse here. So 21 squared plus 28 squared equals C squared. We're trying to find the measure, how we measure this TV. And this is true. Televisions are measured by the lengths of the diagonals. So you can just say it's like a 72-inch TV and not have to worry about length and width. It's a 72-inch that measures its diagonal, and that's a very big television. So 21 squared is 441. 28 squared is 784. So I'm just entering these values into my calculator, and then I'm adding them together and getting 1,225 equals c squared. And actually, what just came to mind, making sure that you guys are following along here with the problems, notice that I'm squaring first and then adding. That's a basic order of operations skill. We're not adding 21 plus 28. If I add 21 plus 28, I get 49. And if I square 49, that's 2,401. That is not the 1,225 that I need here. So we're following order of operations, which says exponents before the addition. So I just kind of skimmed over that before, but make sure that you're adding before squaring, okay? So last step to find C is to square root both sides. So the square root of 1225 is a perfect 35. So this example is a 35-inch television. Final example here, it says a 20-foot ladder is leaning up against a house. Okay, well I don't see a ladder here, so I see a house. Let's see, we got a 20-foot ladder, so it's leaning up against a house. So there's my ladder, and it is 20 feet, and the base of the ladder is 5 feet away from the house. So that's gonna be 5 feet, that's the ladder is 20 feet, and we are trying to figure out how far up this goes. Well, based on this basic picture here, my right angle is down at the base of the house, so my 20, the ladder is C, so that's my hypotenuse, and A and B are my legs. So I'm missing a leg. The 5 is one of the legs, that's the distance the ladder is from the house. So using that information, I can say that A squared plus 5 squared is equal to 20 squared. And I'm going to start solving this for A. So A squared equals 25. Oops, not equals 25, sorry. A squared plus 25 equals 400. Start solving this by subtracting 25 from both sides. And A squared equals 375. Now, we're not done. Okay, this house, and I know that I just picked a picture randomly that I could use, but a 20-foot ladder is not going to get very high up of a 375-story house. This is not 375 feet. It doesn't make any sense with a 20-foot ladder. That doesn't make sense. So we have to recognize the fact that we have A squared here. So I'm going to go back and square root both sides, because the square rooting undoes the A squared and just gives me with A. So the square root of 375, based on my calculator, is another long, lengthy decimal. So you have two choices. If I want to keep my equal sign here that I have, A equals, at this stage, because of where we are right now with remote learning, you can keep it as the square root of 375. That would be your exact answer. If you wanted to approximate it and you prefer decimals, then we would say A is squiggly equals is approximately 19.36. This is approximate measurement, and I need to put feet here for both of those. So the green answer is exact because it is still as a square root, and then the purple answer is your approximate because you had to round a decimal. Now the only thing I will say is that I am going to extend this video just by another minute, explaining, hopefully reviewing how to simplify square roots. That is something that you will need for Algebra 2. So it's not something, everyone listen, it's not something I'm going to require of you right now in geometry in this remote learning situation. But if you are going on into Algebra 2, please take a second and refresh how to simplify something like the square root of 375. If you're done watching, thanks for watching. If you're not, keep on trekking. Okay, thank you for continuing to watch. Let's take a look at the square root of 375, simplifying it. Now there are lots of different ways that teachers show how to do this, and I'm not going to get into every single one. The only thing that I am going to do is I'm going to break down this 375 into a perfect square. Now it ends in a 75, which my understanding tells me that it will be divisible by 25. And so 375 is divisible by 25 to get 15. Okay, 15 does break down further into a 3 and a 5, but there are no perfect squares in a 3 and a 5. Like 25 is my perfect square. That's what I want. So I'm going to leave it like this. So I'm actually going to rewrite this as the square root of 15 times, I'm going to write it as the square root of 25 times 15. Now, the square root of 25 is a perfect square. The square root of 25 is 5. The square root of 15 is not a perfect square. It just gives me another decimal. So that 15 is going to stay underneath the radical, which is what that square root symbol is called. So 5 square root of 15 is the actual simplified answer for the square root of 375. They both are the exact same value, numerical value. You could type them both into your calculator. You're going to get the exact same decimal that we already got of the 19.36491673 and so on. But technically, square root of 375 written like this is not simplified. This is simplified, which will be a skill you will need in Algebra 2. Thanks.